4.4, coordinate systems. I'd like to start with something we're deeply familiar with, the XY plane. I'm asking you to think of a coordinate system in R2. So with my X and Y axis in front of us, if I ask you to think of the standard basis for this coordinate system, I think we're pretty comfortable with 1, 0, comma, 0, 1 as my two basis vectors. So this is what's called the standard basis, and this is what we don't really think about. It's so intuitive to us by now, but over here on my graph, I would say 1, 0 gets me to here, 0, 1 up to there, and from those two little elementary vectors, we can create any spot on this XY plane. So let's talk about something. Let's do a quick example. If I just were to, let's say, pick the point 11, 7. So over 11, up 7, boom. And we'll call that our target vector. I want to end up here. And I only get to use these two basis vectors to get there. Well, I want us to think about our classic matrix equation. How would I put all this together in this format? So A, my matrix, is my basis matrix. I'm going to take my two basis vectors, 1, 0, 0, 1, and create my matrix. Let's hold off on this for a moment. My target vector is what I'm interested in ending up with, what we call the B vector. And I said that was 11, 7. Now remember what this is. This is a common thing we solve for. The X vector, let me just remind you what this really is my weights. I want a linear combination of these two column vectors that end up here. So what weight would I need for the first column to end up with an 11, and then what would be the weight of the second to end up with 7? It doesn't take much to say I need 11 of the first plus 7 of the second to end up with this. So this isn't deeply revealing, but it reminds us of the structure that we've been building all semester towards. Well, here's where things can get interesting. Starting with the standard basis, we're good. But what if we had picked some other basis? And when it comes to R2, I would need two vectors. And I'm going to pick, how about 3, negative 1, and something else weird. How about 1, 5? So let's first verify. How do I know this could be a basis for R2? Well, I need two vectors for sure, and all I need to do is verify that one is not a scalar multiple of the other, and that's clearly not happening here. So what this means is using these two vectors, I can also get to anywhere I want in R2. Let's picture that. 3, negative 1, and 1, 5. So imagine these two vectors now form a new coordinate system. Like the old XY axis, I now have kind of a new XY axis. That almost looks like a 90-degree angle. I don't think it qualifies, but again, that's not what we're even shooting for. As long as these two vectors aren't multiples of each other, they're not on the same line, we can get anywhere we want. And so I still would like to get to my target vector. So let's see how this compares to what we've just done. What would my basis matrix look like? It looks like I would use a 3, negative 1, 1, 5. Hold off for a moment on this, and I'm still trying to hit my target vector of 11, 7. So think about how we've done this in the past. We're eventually going to figure out this, but I want you to introduce you to some terminology and some symbols here. This matrix that's holding this my new basis vectors is called the change of coordinate matrix. The symbol you'll see, they use the letter P instead of A with a little sub B to kind of remind you it's a new basis matrix. So I'll write that name down in a moment. This vector here, which over here was my weights of my column vectors, this is what's called the coordinate vector, and the symbol our book uses is X bar wrapped up with a little sub B to remind me these weights are attached to these new basis vectors. And so we still then finally end up with my target vector. I would like to just call it B like we did over here. It's the same one we have in this equation, but to be consistent with our book, it just calls it X bar as some target vector. So we'll get to that in a moment. Let me restate what is the P matrix called. Our book calls it the change of coordinate matrix. And this X bar sub B is called our coordinate vector. And I just like noticing with the sub B, that just says, it just kind of reminds you we're part of a brand new coordinate system. We no longer are using the standard basis, we're using something else to get my target. So let's just verify. I'll go ahead and fill this in. It turns out if we have 3 of the first column, 2 of the second, we'll get this target vector. And let's verify. Row by column, 9 plus 2 is 11. Bottom row, -3 plus +10 is 7. So let's look at 2 examples for how we pull this together. So let's say we're given a brand new basis in R2, 2 vectors, not multiples of each other, so it qualifies as a basis. Let's say we're given the coordinate vector, and we're asked to find the new target vector. So given these 3 parts, I think all we need to do is set up my change of coordinate matrix, which just holds my 2 column vectors. My coordinate vector, 3, 5, sits next to that. So this is really asking for is, what would my final vector be if I use these 2 column vectors along with these 2 weights? Well, I think we can pull this off. Let me just show it by hand. If I had 3 of the first column added to 5 of the second, (315) (-10), (-20) gives me my final target vector of -7, -5. Boom, we got it. All right, second example. What if we're given a basis for R3 and we're given a target vector? How do we find the coordinate vector? So let's remember how we've thought of this in the past. I'm going to go ahead and build a matrix with my column vectors. Now remember, I don't have my weights. What I do have is what my target is, what we normally have called my B vector. And how did we usually find those missing weights? Is we augment this matrix with my target, and we are back to one skill we've done many times in this class. I'm going to row reduce this with a calculator to make things go quick. And it turns out we end up with the identity matrix on the left, which is great for us, and this on the other side. So it looks like we have just found my coordinate vector is 1, -1, +1.